And we'll begin. We've already done example 1, but we will begin on this slide because they don't have example 2 on the slide. Sorry there's only 2 people here, but I'm glad the 2 of you are here. I'd much prefer this to talking to an empty room. I do have a couple of announcements. One of them is pretty important, too. How many have done the student course evaluations?
Halfway through.
Halfway through.
I don't know that.
Huh?
I don't know what that is.
You don't know how? Is that what you said? I can't hear well.
Oh, I don't check my email, so.
Okay. Yeah, it's a good idea to check them. Okay. Huh? Yeah. And it's all you have to do is click then. You can get to it otherwise, but it's a lot easier if you check your email. But you can go to quick links and scroll down and look at things and finally find it, and you can get to it that way too. But it is easier if you have that email. But anyway, this probably doesn't affect you directly, but it does a little bit indirectly. Coming up in a few years, I think it's 2 or 3 years, and y'all may be gone by then. You probably hope you're going to be gone by then. But we're going to have our re-accreditation visit from SACS, which is Southern Association of Colleges and Schools, which is the accrediting agency for all the 2-year and 4-year colleges, universities, grad schools, things like that in the Southeast. Now, it seems like a long way away. For y'all, maybe it is. For us, it's not that long because they start looking, when they get here, they don't just look at what we've done the previous year, they look several years back. So we're beginning now to get our ducks in a row preparing for SACS coming in 2 or 3 years. One of the things that we have sort of gotten a little slack on, and I don't know why this is happening. Well, last class it did too. I suddenly get sneezing fits. And then that opens my head, and here comes the drainage. So sorry about that. Could be in a rough period this time. But we've gotten a little slack, and I think our participation in our student course evaluations have actually probably gotten less than 50%. I don't know for sure. Someone gave a figure that was considerably less than that. I don't know if that's correct or not. But Brittany is here. And I'm going to be sneezing all morning, I think. I don't know if there's something in the room I'm allergic to or what. Because when I was out in the hall, went to my office, no problem. Came back in here, and here it goes again. But we really need those student course evaluations. They're saying now we need 80% participation. Now, if all 3 of you did it, that still wouldn't be 80% of this class. So all 3 of you, please do it. But the other members of the class, that's why I'm putting this after I started recording, we really need those student course evaluations. Have you done yours already, or student course evaluations? Okay, you got an email sometime. Do you remember when that email came? Anil?
Yeah, 2 weeks ago before.
2 weeks ago, okay, about your student course evaluations. So if you go back and check your emails, there's a link there, you click on it, you're right there. You don't have to go that route. You can go to the website and then go to quick links and then scroll down until you find evaluation. And then once you find that, then you can click on it. It's much easier to do it through email. Just one click and you're in. Okay, so please do those. Now, you can wait until after the finals, after you see your grade to do them. But I would not recommend that, because I remember, even though it's a long time ago, when I was an undergraduate, as soon as that last final was over with, I cranked it off and was heading home. You know, I didn't want to think about anything else for a while. Okay? So, don't do that to your student course evaluation. If you think you might, go on and get them done now. Okay? But you certainly can wait if you wanted to. some of them are actually saying don't give the final until the people have done the student course evaluations. I don't think that's fair. I think you ought to be able to do it anytime you want to. And if you want to wait till you see that final exam or your final grade, you certainly should be able to. But in the real world, I mean, I imagine you're not going to change much from now to then. So please get those done. So that's the first major announcement. Please get your student evaluations done. Second one is a lot more minor, but I just wanted to let you know in case any of you would be looking for this. Normally on Fridays, I'm on the Birmingham campus, office hours 7:45 to 11:45. Not this Friday. I have an infusion scheduled for Friday. I will be at the Kirkland Clinic before 7 o'clock, and I'll be there until after probably 4:30 or so. So it's an all-day affair, and when I get through with it, I'm not going back to campus. I shouldn't drive that far. I'm going to make my way home and get into bed. Okay, so that's typically what I do, because they give me, Benadryl and stuff like that, and that sort of knocks me out. I don't take medicines well. I mean, here's Ilsa. And I don't know why, but about the middle of my last class, I just started sneezing and my nose started running. And when I go down the hall or in my office or something, nothing. It's just this classroom. I don't know what's going on in here. But that's why I'll be sort of congested, I guess. And the big announcement was, please do your student course evaluation. Have you done them yet? There was an email that came out a couple weeks ago. Go to that and you'll probably see. Huh?
I said I might have done it. I can't remember.
Okay. All righty. All right. So let's move on. We were on example 2 in chapter 6, Law of Sines. 6.1, Law of Sines. Chapter 6 is additional topics in trigonometry. 6.1 is Law of Sines. And this is Chelsea, right?
No.
Huh?
Kanisha said.
Kanisha, sorry.
That had changed my schedule. And so then they took me back to my old schedule. That's why I could be here.
Oh, okay.
That changed my schedule. And then he told me that I had to keep the classes I had. Or whatever. So now I'm back.
Okay. Do you need any of the tests?
Yes. I need like every test y'all have.
Okay. Okay. Did you never get even the first test? Okay. You know about your paper too, right?
Yes, sir.
All right. Chaston's here and Whitney's here. Okay, you know about the paper, right? Okay.
As far as the midterm,
I'm sorry?
the midterm.
We've had 3 tests. You can count one of them as a midterm if you wanted to, but they're just 3 tests. They're all equal. Okay. Okay, why do I not have another copy? Someone must have gotten more than one copy of the test. Let's see, make sure. I'm going to have to run off a copy of test 1. I don't know.
Okay, that's fine.
Okay. So let me. I'll do that after class.
Okay.
Okay, wait, let me give you test 2 though. I think I have a copy of that one. Test 2. Do you need graph paper?
No, I have some right now.
Okay. There's the first 9 of those need to be graphed, so take several sheets. Okay. But you can do more than one on a page if you want to, front, back, whatever. And then the third test, we just had it out recently. So after class, I'll make you a copy of the first.
Okay, thank
I
you.
don't know why I don't have it. I'm guessing someone messed them up and took an extra. All right. So, since several people have come in since I made the announcement before, please do your student course evaluations. Okay? They're really on to us about them. They want 80% participation. And if, that's really pressing it, because I have a few people who have not been here since the course evaluations have been passed out. So, or, they announced them. So that's probably part of the 80% that we're not going to get. And then one person didn't pay. Depending on what they base the 80% on, we need everybody to do them as soon as you can, but whenever you want to. All right, we're on example 2 on page, let me get my pen activated, on page 403, chapter 6, additional topics in trigonometry, 6.1 law of sides. All right, here's example 2. I'm going to have to sort of draw the picture. It's kind of an ugly picture, but you'll have to live with it. Okay, here we have nice level ground, supposedly. Okay, and here we have a pole. It could be a power pole or something like that, but whoever planted it did not do a very good job. Okay, it's tilting away. It's not at 90 degrees with the ground. The pole tilts toward the sun, so the sun is up here somewhere. Okay, maybe not right there, but somewhere up there, at an 8-degree angle from vertical. Well, here's vertical. That's 8 degrees. Now, probably mine is a bit more than 8, but mine's exaggerated, so live with it. I'm sorry for those who just came in. I explained to the others. About the middle of my last class, I just started sneezing and just could not stop hardly, and now my head is running. It's crazy. And I went to my office in between classes. I went to down the hall. Stops when I'm not in the classroom, but something about in here is just driving me nuts. Okay. So this pole tilts toward the sun at 8 degrees from the vertical. It casts a shadow that's 22 feet long. So here's a 22-foot shadow from here to here. So obviously I have the sun in the wrong place. It should be much lower. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. So if you're standing down here at the tip of the shadow looking toward the top of the pole, this is a 43-degree angle. Now, mine looks a little greater than 43, but again, live with it. Sorry. I don't know why my head's running like this. Okay. The question is, how tall is the pole? So the answer is this. Now, in the book, they name this A. That's going to be the height of the pole, the length of that side. If they name that A, this angle over here must be capital A. Now, it doesn't matter to me what you name the other 3, just to make them the same as the book, since we don't have the slide. They named this one B, so this side over here would be little b. They named this angle C, so this side down here is C, little c, which is 22 feet. So let me write it down there. And again, I'm sorry. Sounds so bad. That's little c is 22 feet. And angle A is your 43 degrees. Okay? Now, how would you go about solving that problem? We're looking for A. We don't care what B is. We don't care, well, sort of. We don't care what side B is. Not quite, but we sort of do. How are we going to do this? Any hints? What is our procedure here? I think I'm just going to leave this out. How do we get side A? Number one, you know it's not a right triangle. If it was a right triangle, no sweat. It's not a right triangle. So how do we do it? Help me. What's the name of this section? What's the name of this section? Law of signs. Maybe the law of signs might help, huh? How does the law of signs go? All right, this is Mike. Yeah, I'm trying to find you. No, you're in here. There you are. Okay, is anyone else coming in since I called roll? Okay, again, let me say this because I need to say it to everybody who's here and not here. We really need the student course evaluations done. The dean and those up there have said we need 80% completion rate at least. We don't even have 80% of the people in the class here today, so we've got to have everybody doing the student course evaluation if possible. All right, so I heard someone mention law of signs when I prompted and prodded. So how does the law of signs go? Anyone remember what the law of signs is? Anyone? I know it's a long time and a lot of turkey since Thanksgiving, since we met before. Anyone remember how the law of signs goes? All right. Leg A, or side A over sine of angle A, is equal to B over sine B. That's angle B. And that's also equal to C over sine C. Pretty simple formula there. Okay? Chelsea, right? Okay, I'll say it every time someone else comes in. The administration is really on us to get all the student course evaluations done. They want at least 80% done this term and from now on, because we've got a SACS visit coming up in a few years, and they're going to be looking back at our data. And our data are not looking good now because we've had low participation for the last few terms. So please do your student course evaluations. All right. How does that pertain to this problem? What do we know? What are we looking for? Well, they gave us two things, didn't they? They gave us an angle A, that's going to be useful, and they gave us side C, which is going to be okay. We can't use that. We can't use the law of signs. We've got to have 3 out of the 4 of a ratio, of a proportion. We only have 2 things now. So we've got to come up with something. Oh, they give us something else. They gave us 8 degrees here. How can we use that? What does that tell us?
You know the other angle here.
B you mean? Okay, what would that make B to be?
What? We already know it's 90.
Yes, this is 90. And that's 8 more. So that's going to be 98 degrees. Very good. Parallels here. That's very good too. Okay. Now, I'm going to say it every time someone comes in, so you're going to hear it over and over again. Please do the student course evaluations. They're trying to get us up to 80%. And I hear people suggesting things that I don't think are very good. They're saying, don't give people their final exam until they've done the student course evaluation, and that kind of stuff. I feel like final exams are stressful enough. There's no reason putting extra levels. So do me a favor, do yourself a favor. Get them done ahead of time so you don't have to worry about it. So please do this to the course evaluation. Okay. Now, sorry. So now we have another piece of information. Angle B down here is 98 degrees because it's 8 degrees past vertical. Vertical is 90 degrees, so that would be 98 degrees. Here's the bad news, folks. Well, we have three pieces of information now, but we don't have a single bit of information that relates a side to an angle. We have two angles with no side, no knowledge of the sides, and we have one angle that we don't know the angle, but we do know the side. So we can't use law of sines yet, but what can we do? It's right there, trying to smack you in the face. Say again? You can find the other angle, absolutely. How do you find it? How do you find the other angle? Help. How do you find the other angle? Say again? I know you know this.
You can find the angle for the 90-degree triangle by subtracting the angle you know from the
Okay, I think I heard you say something like, you know that the three angles of any triangle add to 180 degrees.
So the angle is 98.
Okay, this angle's 98, that angle's 43. So what do you do? Add them together. What does that give you?
And
141, right? Okay, subtract that from 180. 39. So this angle up here is 39 degrees. Ding, 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 ding! We now have a ratio we know. We have angle C and side C. Once you know that, you can then determine what side A is. How? Law of sines there. Forget about the B. It was nice to know it, but we really don't need it now because we don't know side B. We'll use the A's here. So side A is what you're looking for. So A over what? A over what? The sine of 43 degrees is equal to, what's your C? Little c? Second? 22 feet. I'm going to put the units in there. Usually I don't, but just for remind you, over what? Sine of 39 degrees. Is that what you told me it was? Okay, 39 degrees. Sorry. Sorry, folks. All right, now we have a proportion. You know, 3 out of the 4 pieces is easy to come up with the 4th piece. How do we do that? Excuse me, how do we do that? Say again? Yeah, you'd cross multiply. And this gives you A times the sine of 39 is equal to 22 times the sine of 43. Does everybody see that? Okay? Now you can divide both sides by sine of 39 degrees. And that will give you what A is. If someone can punch that in on your calculator. Notice how violent we are in the South. We punch things in on the calculator. Up north, they press things. Never mind. What does that give us? Anybody? 23 point what? Okay, so let's call A approximately 24 feet. You said 23.81? Second? 84, okay. Well, since we only have two significant digits here, everywhere, let's not do any more than that. So round that up to 24. And does that make sense? The smallest angle, that's the smallest side. The medium angle, that should be medium. A little bit greater than that, and sure enough it is. If we had done B, we'd find out that's the longest side. But who cares? We don't care what that distance is there. All we were interested in is how tall the pole is. Let's see what they got. They said 23.84. I contend you don't have enough significant digits to get that kind of precision, so I rounded it to just 24. All right, as in just about every one of these examples, I believe every one of them, if you see an example, there is a checkpoint. And somewhere in the back of your text, I think they have the answers to all the checkpoints. Okay, I know they do in mine, but I think they do in yours too. All right, any questions on that? I'm sorry, I may have to go down to the hall and clear my head again. I'm going to try not to, but this is flowing like a fountain. Not a very pretty fountain. Okay. So, whoa, wrong. All right. That was the other problem, example 1. All right, we're going to move to the ambiguous case, and I'm sorry, I'm going to have to put it on pause and go down and clear my head. So I'll say it again, please do the student course evaluation. All right, now we're going to look, see the law of sines is a pretty nice handy-dandy little formula, except sometimes it just doesn't work because physically you can't use it. And that's called the ambiguous case. There are other times where you can use it, but you don't. It'll give you actually two different answers. That's the ambiguous case. And that's when you have side-side angle. And remember, we always say side-side angle. We never say angle side-side, do we? Never mind. Okay. All right. Because of the abbreviation. Okay, never mind. All right. So, in example 1, we saw that two angles in one side determine a unique triangle. However, in fact, let me say this. Okay. This happened this morning. I came in, everything, I felt fine, everything was good. About midday through my first class, I just started sneezing. And ever since then, I haven't been able to stop sneezing. And when I'm in the hall, when I'm in my office, nothing. It's only in this classroom. I just can't stop sneezing, it seems like. Okay? I don't know why, what's causing it, I do not know. Maybe the air is blowing down on me, I don't even feel that, but I just can't stop sneezing. Okay, here's what I was going to say. And it's what we ran into last time. If you know two angles of a triangle, guess what you also know? The third angle. So any triangle that you have two angles to and one side, it doesn't matter if this side is opposite one of those two because you know all three angles. If you know two angles of a triangle Add them together, subtract from 180, you know the third one, and then this side has to be opposite one of those. And then you can use the law of sine. Okay. However, if you have two sides and one opposite angle given, two sides, one angle, side angle, then here's your three possible situations. Okay? Sorry about my head. Okay? It may be that there is no triangle that would fit at all. And here's why. You have two sides and one angle opposite. So let's say we know this angle and we know this side and that side. Okay? What if this side is too short to reach the base of the angle? You can't have a triangle there. Okay? So that's one possibility. It could be that one triangle and only one exists. And if that's the case, fine, you can solve it. However, there's a third case, and this is the ambiguous one. You may have two different triangles that both satisfy those conditions right there. And that would be if the third side can go over here or over here, then you have two triangles and you don't know what. They fit this, that, and this, but you don't know what the others are. That's your ambiguous case. And it's also ambiguous whether you even have a triangle to work or not. And here's the situation for that. This is the one I described to begin with. So you have an angle here, but you don't know this side, you know these two sides. Well, this one's opposite that, and you would think law of sine should work, right? Well, not necessarily. If this side A is less than your H, in other words, if you do, the sine of this angle would be H over B. If this A is less than H, there's no way. That just is going to be up there dangling. It's not going to form a triangle. So if A is less than H, there's no way that could work. And H is B times the sine of theta. Okay, sine of A. No triangles possible. Okay, now there's three cases by which there's one and only one triangle. If that A is exactly equal to H, you have a right triangle. That's the only triangle you can have. Well, that's fine. You don't even need the law of sine then, because that's the right triangle. You can figure out everything you need from that. If A is greater than B, then you're only going to have one triangle. That is the simplest case. You don't have a right triangle necessarily. No, you won't have a right triangle. A is greater not only than H, but it's also greater than B. Okay? Now, here's the one that you have two possibilities. This is your ambiguous case. If A is in between H and B, you could have a triangle that way or this way. Either way, that's your ambiguous case. All right? Now, if your angle A is an obtuse angle, and that means this is the largest angle in the triangle if you can form a triangle, but this is a shorter side than that, there's no way that will work at all. If that's your largest side, that's got to be, the largest angle, that's got to be the largest side. If this is less than that, there's no way it'll work. And the other case is if A is an oblique triangle, an obtuse triangle, okay, then it's oblique also, it's not right, but it's obtuse. If A is greater than B, then there's only one way that will work. Only one way. Okay? So this is why it's ambiguous. Okay? If A is shorter than H, no way it's going to work, because H is always shorter than B. Okay? If that's an acute triangle, acute angle. If A is equal to H, you get a right triangle. If A is greater than B, you always will get a triangle that works. But if A is in between H and B, then you'll always get two possibilities there. If you got an obtuse angle and A is less than B, there's no way that can work. But if A is greater than B with obtuse angle, it will always work. One and only one triangle. Okay. I'm so sorry, folks. All right. So, let's do example 3. For the triangle in this figure, where A is 22 inches, here, that must be angle A over there then. B is 12 inches, that must be angle B then. And A is 42 degrees. Find the remaining side and angles. Okay? Now, how would you solve that? Find the remaining side and angles. We have side C we don't know, and angles B and C be the one that we know. How do we do this? Excuse me. How do we do this? Huh? That works for right triangles. This is not a right triangle. So what do we use? Law of sines, exactly. And this is a dead giveaway here because the side opposite the angle we know the side and the angle. That should be a dead giveaway that we at least have a chance to use the law of sines. Since they've drawn the triangle, you know it does exist, okay? So there's no doubt about that. But if you were using the things before, anytime A is greater than B, you will get a triangle out of it. You can't help but get one and only one triangle out of it. So we just use the law of sines straightforward. And how does that go? Little a over sine capital A. Little b over sine capital B. Okay? That's a good one to do because you always want to use the ratio you know, and you want to solve for the ratio you don't know one piece of. We know one piece of that, but not that one. So let's solve for sine B. So how do you do that? Say that again. Okay, you said 22, I can't hear well, over the sine of 42, that's correct, equals 12 over the sine of B. Perfect. Now, actually, folks, many times you'll read in sometimes physics books, certainly math books, they will talk sometimes about solving the equation literally or plugging in the values and solving it. What I call this plug and chug, and the other way, if you're looking for sine B, then just solve this for sine B, that's chug and plug. I know you can call it anything you want to. So yeah, we're looking for sine B, so that would be 22 cross multiply times the sine of B, which we don't know, is equal to, cross multiply here, 12 times the sine of 42 degrees. Okay? So we can divide both sides by 22, and that will give us sine B. So if someone wants to punch that into your calculator, see what you get. Is equal to what? Bless you. A little louder.
36.
You've already done the inverse sine? Did you just plugged in those numbers and got 36? may be right, but did you do an inverse sine? How did you? You don't get a 36 here. 12 divided by 22 is less than 1. Sine is less than 1. So that gives you a decimal number. 0.36. Is that right? Is that what you got?
That's what I got, but that's not the answer.
I'm sorry?
I said, yes, that is what I got, but that's not the answer.
Okay. So you got 0.36. Is that what someone got? 0.36. Okay. We want to know what the angle is, not what the sine of the angle is. How do we get the angle out of that? Help me out. How do you get the angle out of that? Now, I would leave all those digits on your calculator. You may have rounded to 0.36. I'd leave them all there. Well, times sine of 42 divided by 22, it's going to give a whole string of numbers. And then what do we do?
Okay, that's what you did.
That's when you do the inverse. That's why I wondered if you had already done that. Inverse sine of whatever that number was on your screen, what does that give you?
21.35.
Say again?
21.35.
21.35, is that what you said? So let's just round that to B is approximately equal to 21 degrees. Now, I would definitely stop and ask myself, does this make sense? Well, obviously, this side is greater than that side, right? So that means this angle had better be greater than that angle. And even the picture looks like it is. Indeed it is. In fact, that's a very reasonable answer for that to be that much less than this one, because that side is much shorter than that side. So yeah, I feel pretty good about that. Okay? So that's given us one angle. Angle B, about 21 degrees. All right. So what do you want to attack next? What's the easiest thing to do next? C. That means yes in Spanish. Okay. Which C are we talking about? Big C or little c? Yeah, the angle C. What is it? That's really easy to get. Why? You add the two of those together, you get 63. Subtract that from 180. Is what? How much? 117. Okay, I don't hear well. 117 degrees. That's your angle C. All right, so we got two of the three unknowns, the two angles. What's the only unknown we're missing? The side C, little c. How would you go about getting that? The law of sines. And which law of sines would you use? Okay, definitely use A over sine A. Why? Because they gave it to you. You know those are correct, accurate. If you use one of the things you've already calculated, you may have made a mistake. So use the ones that we know, okay? But what will that equal? Excuse me. What would that equal? Excuse me. Excuse me. Excuse me. What would that equal? Say that again. Well, I mean, in terms of the law of sines. Say again. C over sine C. Okay? We know three of these now. This one, sure, we're going to have to use capital C that we calculated. We can't avoid it, but that will give us, do you want to plug first or solve first? I don't care. Plug, okay? That will be 22 inches, by the way, is to sine of 42 as C, which we don't know, is to sine of 117 degrees. Okay? So that means when you cross multiply, C times the sine of 42 degrees is equal to 22 times the sine of 117 degrees. Okay? I can't read my writing there, but I know that's what it is. If you divide both sides by the sine of 42 degrees, then you get what C is. Someone tell me what it is. (22) times the sine of 117 divided by the sine of 42. Second? 29 point what? 40. So let's say that's approximately 29 inches. Okay? Let's see if that makes sense. Okay? Well, it's pretty obvious to me that this is the largest side. Angle. It's got to be. So this had better be the largest side. Certainly it's larger than that and also larger than that. I would have almost guessed it to be a little bit greater than, a little bit bigger than 22 by a little bit more, but no, that looks about reasonable. If you break this down here, that would be, it looks like that's pretty reasonable. I'm sorry. Sorry. Yeah. Now they round to more digits than I do. I'm sorry. Where this is coming from. All right. So, sorry. Yuck. So, they started the problem just like we did. We knew side B, we knew angle A, we knew side A, so we started off calculating what sine B was. Now they flipped them over. Doesn't matter how you write them, as long as you have the ratios right. If you put sine over length, then do the other sine over length. If you do length over sine, do the other length over sine. Doesn't matter how you do it, but do it, okay? Now, what they tend to do, and this is why I asked, we obviously like to plug and chug. They like to chug and plug, okay? Because the next thing they do is solve for the thing we don't know. We knew B, sine A, and A, so we divide both sides, multiply both sides by B. So that's what they did without plugging the numbers. It doesn't matter which way you do it. This doesn't work just as well, but no better than the way we did, okay? So then we get that by plugging in 12 times the sine of 42 divided by 22. Same thing we got. That gives you, and they didn't show you how, that gives you a decimal number. Then you do the inverse sine of that to get your angle. And I round that to 21 degrees rather than carrying. Since your original problem only gave you 2 digits there, 2 digits there, and 2 digits there, how do you get 4 digits in your answer? I don't know. So I round that to 21. Okay? Once you've done that, you've got 2 angles. As soon as you get 2 angles, find the third angle. Subtract and that just, it looks ridiculous to be having the one that gave you 42 and then the other one 21.41. There's just not any justification for using that many digits if you don't know. If they had said that was 42.00 degrees, yeah, then you're justified to do 21.41 degrees. Because the 180 you know is to as many decimal places as you want to. So I just don't concur with that. You can. They gave you 116.59. I rounded that to 117. The remaining sides then would be side C. And you could have done the law of sines with either this one or this one, or B over sine B. But since your sine B you calculated, stay away from the calculated one. Use the ones that were given. They gave you A, they gave you sine A. Here you can't avoid using C, so only use one thing. Otherwise, you'd be using two calculated values, which could have round-off errors. So use as many of the original as you can, and then solve for little c, which will be multiplying both sides by sine C. A sine over sine A times sine C. You plug those in, and you get 29.4 inches, which I would round to 29 because you only had 22, 42, or whatever. Everything was 2 digits, not 4 digits. So I'd round that. Okay. That was the easy one. They showed you the answer to they worked it out for you on the slides. The two that are not easy, they didn't show you. So let's do example 4 and then 5. Okay, let's do example 4 here. Show that there is no triangle for which little a is equal to 15. They don't give any units here. Little b is equal to 25. And sine and A, capital A, the angle A, is 85 degrees. All right. Now, I'm first going to give you an approximate view of this. This isn't exact, but at least gives you an idea. If angle A is 85 degrees, it is going to be very, very hard for angle B to be very much larger than that. Why? What do the three angles of a triangle have to add to? 180. And if you subtract 85 from 180, what do you have left? 95. That means the sum of the other two angles has to be 95 degrees, right? So yeah, you could have one angle at 90 and one at 5, and 85 could be in the middle. But I guarantee you then that little a and little b will be very close to each other. Yeah, b would be bigger, but it's not going to be that much bigger. There's no way this is going to make a triangle that works. A is too short. For that to be that big of an angle and that to be that big of a side, there's no way you can have that small of a side. This is not going to form a triangle. But you don't have to take my word for it. What could you do? What's the name of this section? Law of sine. So let's do it. Let's try to do it anyway. What would we have here? What would law of sines tell you? Little a over sine of big A is equal to little b over sine of capital B, right? And we're looking, we know this one, we know that one, we know that one. So we're looking for sine B. This is the one we're looking for. So let's do our cross multiply. And you have that A times sine B is equal to B times the sine of A. Agreed? Okay, let's plug in what we know. Well, let's first divide by A, little a, because we know that. All right? So this gives us that sine of B, capital B, the thing we don't know, is equal to B, which is 25, times the sine of 85, right, degrees, divided by 15. Someone punch that in on your calculator. Say again? 4.6? Oh, 1.6 what? 1.66. Okay? 1.66. What angle has a sine of 1.66? Say again? None! Why? Sines are always between plus and minus 1. Sines and cosines are always between plus or minus 1. You can never have the sine of an angle be greater than 1 or less than minus 1. They're always going to be between plus or minus 1. Can't happen. Because if you had that number, you got it on your calculator now? That number? Do an arc inverse sine of that. Or you got it in your calculator. What do you get? Error! You can't happen. So if that's what you get, you can say no solution. There's no way that can be true. He said this was 1.66. As soon as you see that, no solution. Now we had already thought through it and doubted we could have a solution. This proves it. No solution. Right? All right. Sorry. There is a checkpoint like there is after each of these examples. Go home and do those, or go to the next time you have free time, do the checkpoints. All right, let's move to examples 5. They tell you now this is a two-solution case for side-side angle, never angle side-side. Find two triangles for which A, little a, is equal to 12 meters, big old triangle. Little b, I'm looking at the wrong one, little b is equal to 31 meters. Whoa, really big triangle. And angle A is equal to 20.5 degrees. Now, in this problem, I will allow a single decimal place for your angles. But for your sides, you better keep it to two digits. Okay? It just doesn't make sense otherwise. All right? Now, where would you go from here? Where would you go from here? Law of sines. And how does that go? A is to sine capital A as little b is to sine capital B. Now, you want to plug and chug or chug and plug? Plug and chug? Okay. We'll fill in what we know. 12 meters is to the sine of 20.5 degrees as 31 meters is to the sine of B. Okay? Now, what will you do from here? Second? Divide by what? Okay. Actually, I find it easier to do cross multiplication. Okay? And then you can divide by 31, but then you're going to have to multiply by some. But you introduce more steps. If you just do your cross multiplication, you have 12 times the sine of B is equal to 31 times the sine of 20.5. Okay, degrees. And then you can divide both sides by 12, and you only have one division there. Okay, and that will give you, now I didn't keep the units on it, but if I had, the 31 is meters, the 12 is meters, the units cancel out. So that's why I dropped the units, because I knew they would. So this gives you the sine of B equal what? 31 times the sine of 20.5 divided by 12. Or 31 divided by 12 multiplied by sine of 20.5 degrees. However you want to say it. What you get that to be? Second? .90. 0.90. Okay, you probably have more digits than that. Don't throw them away. Okay? Now, just looking at this and proceeding as we have before, does it look like my bulb's starting to go bad? Do y'all see a flicker, or is that me? Okay. I'm afraid I'm about to lose my bulb. Okay? All right. Anyway, what would you normally do at this point? What would you do at that point? You've gotten there before in problems. What would you do?
Subtract from 180.
Second?
Subtract from 180.
Okay. This is the sine of b is equal to this. Not b is equal to that. The sine of b is equal to that. We got to get b first before you can do it. Subtract.
Inverse.
Inverse sine. And what you get? If you've still got all those digits on there, do the inverse sine of it, and what you get? B is approximately, say again? I can't hear. 31? 71. 71 degrees. Well, let's do it to the nearest decimal point. One more decimal point. 0.3? Okay. All right, 71.3 degrees, because they gave us a 20.5 before. Okay. Now, here's the thing, and folks, this is where you have to, there's nothing that indicates you have two cases here, unless you went back and did your analysis like they showed you in that figure they had. But when you have an angle that's close to 90, remember how sine goes? Sine starts here and goes up here, but also, so we're over here at 71.3 degrees. And for that same value, you could be just on the other side of 90 and also have an obtuse triangle. Okay? So basically what you do is subtract this from 90. That would be 8.7, right? 18.7. And then add 18.7 to 90, that would give us 108.7, right? So there's another possible angle. Either this or 108.7. What's that? Subtract it from 180? Yeah, that works too. Okay? Now, and you see you have these two possibilities. It could be, B could be a small angle, or it could be a large angle. It could be acute, or it could be obtuse. Okay? So you have two different triangles you can go on now. One is the B of this. So what I'm going to do, I'm going to put this as B small and make this B large. Just so I can keep calling it B, but your smaller option and your larger option. From here on, you have to do everything with both of them. So what's the next thing you would do? If we're dealing with B small, here's what I'm going to do. I've decided to do it differently. I'm not going to call it small and large because other thing. Let's call it B acute and B obtuse. So BA and BO. Okay? And could be either one. Okay, never mind. Okay. So, let's go with the acute first. What would you do next? So right now we have a side, an angle that was given. We've just calculated another angle. So where would you go next? You hit it several times a day, and every time it seems like it stumps you. If you have two angles in a triangle, guess what? You know the third one, so let's go. What's the third one? Add those two together and you get 91.8, right? Is that right? Subtract that from 180. I think I did it right. 91.8, subtract that from 180. And what does that give you? Is it 88.2? No, I can't subtract. What's that? You gave me the wrong number. Why did you do that? Okay, what number did you mean to give me?
64.7 for B1.
Okay, let's start over, folks. Okay, not all the way over. For B, okay. I thought that number wasn't sounding right. Okay. Whoops, we could have left that. Okay. Now. So what was B? 64 point what? 64.7 degrees. Okay? That would be your acute angle A, B. What would be your obtuse angle B? You said just subtract that from 180. Does that work? A little louder? 115, you said? 115.3? Yeah. Okay. So there are two angles. Okay. Now, okay, this was 180 up here that I started to erase but realized I didn't need to. Let's do, for the acute triangle, let's add together 20.5 and 64.7. That would be 85.2, right? So subtract 85.2 from 180, and that gives you 94.8. Is that right? Did I do it right? $85.2, subtract that from 180. I think that's right, isn't it? So now I'm beginning to regret it again. This is not a good name for it, acute and obtuse, because the C is going to be different. Okay, but we'll do this as your C. I'll keep it CA, though that's not an acute angle. Okay. 64. They got 64.8. You gave me 64.7. If we make that 8, then we'll make that a 3 and make this a 7. So 94.7. Yeah, 94.7. Okay, from that point on, you can use your law of sines again. Okay? And again, I would use the one you know, and then use that angle C to get your side C. But then we go back and do the same thing again Now that would be 115.2 then. Okay. And then you go through and do it again. So you see you get two different triangles. The first one, B, is an acute angle, but C is obtuse, not very obtuse. The other one, B, is very obtuse, and that makes C fairly acute. Okay? It's got to be acute, but it's going to be smaller. And you go through and use your law of sines again. Can y'all do the rest of that at home on your own? So this gives us two triangles. Both of them work. Both of them fit perfectly. You would just have to know something else about it, whether you have a big acute obtuse angle like B or a smaller obtuse angle like C. Okay. But you get two of them, and there you see them in your text. We didn't get to finish them, but we got pretty close. There is a checkpoint there, so please do that. We'll begin next time with area of an oblique triangle on the top of page 406. So let's see. We almost finished 6-1, folks. Got close. Homework exercises do either 5 or 7 or both, and do any of the odds 9 through 23. Then do any of the odds 25 to 33, either 35 or 37 or both, and stop there, and we'll pick up with 39 next time. Okay? All right. Good deal. All right. Just to look ahead, we're going to finish 6.1 on Thursday, get going on 6.2. Hopefully we'll make good progress there too. And then we'll get into 6.3. Hopefully we'll get 6.3 done, and possibly even 6.4. I'm doubting we're going to get to 6.5. I wish we did, but it's something you can live without. Office hours what? Today. From 1:15 to 3:15. Okay? We'll see you Thursday. Please do your student course evaluations. Oh, good deal. Thank you.
Yeah.
Test 2. Got it.
Yeah.
Test 4 will be the final.
You have to give it right.
No. Have you got test 3? Okay. Test 4 will be up to chapter we are now. We got to see how far we get.
Also, that's 2 anchor.
I'm sorry?
That says 2 anchor.
This is test.
Like,
oh, yeah. Turn in test.
both of them.
Right.
Do you curve grades or?
Usually if I drop the lowest test grade, it gives me a pretty good.
Okay.
Do you want for the test 1? Do you want me to get that on Thursday?
I can give it to you now. Let me just end this. Do you have something you got to go to now?